Good day and welcome to AP Calculus Lecture 2.5b, where we continue on working implicit differentiation problems. I'm just going to work in this lecture 3 problems from the book, from page 139. So we'll start with number 10, where we're trying to find dy dx. All right, so we want to take the derivative with respect to x of 2 sine x cosine y equals 1. Okay, so right here we have a product rule. So it's the first 2 sine x times the derivative of the second cosine y. So that would be times negative sine y. But anytime you have a y, we have a dy dx. So derivative of cosine is negative sine, and then the derivative of y is dy dx. So that's the first times the derivative of the second plus the second cosine y times the derivative of 2 sine x. That's 2 cosine x. Right, equals 0. The derivative of 1 is 0. Well, let's clean this up. So this is minus 2 sine x sine y dy dx. And I'm going to go ahead and move this term over to the right. So we'll make it negative is equal to, and let's put the 2 first, minus 2 cosine x cosine y. Now solving for dy dx, I'm going to bring that minus 2 sine x sine y underneath. So I have minus 2 cosine x cosine y over minus 2 sine x sine y. The negative 2's will cancel. So we have cosine x cosine y over sine x sine y. Now, on a test, I would be totally fine with this level of simplification, but you can go one step further. Can you think think about that for just a second? What is cosine over sine? Well, it's cotangent, right? So this could be simplified even further into cotangent x, cotangent y. And if you did that, I would be super proud. But either of those are acceptable. All right, let's work another one. Okay, the next example is 14. And that one we have cotangent y is equal to x minus y. And I'll go ahead and skip writing it again. We're going to take the derivative with respect to x of that. All right, what's the derivative of cotangent? It's minus cosecant squared y. But don't forget what? The derivative of y now is dy dx. Easy thing to forget. What's the derivative of x? It's 1. And the derivative of y is dy dx. Now let's move that dy dx over to the left. So we'd have minus cosecant squared y dy dx plus dy dx is equal to 1. Let's factor out a dy dx, and what you'll have is negative cosecant squared y plus, this is something that students forget all the time. When you factor a dy dx out of a dy dx, it doesn't just go away. It's 1. Now the book will write this as 1 minus cosecant squared y, but I didn't want to do that right away. Now, So dy dx, bring that minus cosecant squared y plus 1 underneath. So 1 over that is perfectly fine with me. A little prettier way to write it is 1 minus cosecant squared y on the bottom. That's the way the book will do it. I'm fine with either way. They're exactly the same thing. All right, that's 2 of our examples. Let's do one more. Go to number 18. So 18, not only do we take the derivative, we evaluate it at a point. So with 18, we have x squared minus y cubed is equal to 0. That's not going to be too hard. And we have to evaluate it at the point 1, 1. Well, we like 1. Only thing better than 1 is when we evaluate zeros, right? Okay, let's take the derivative with respect to x of that bad boy. All right, we got 2x minus 3y squared. Are you done? No, you also have the derivative of y. dy dx equals 0. So 3y squared dy dx, that's a negative, sorry, is equal to negative 2x. If we move that over to the right, so dy dx is equal to negative 2x over negative 3y squared. The negatives cancel, so we have 2x over 3y squared. So evaluating that at 1, 1, we would have 2 times 1 over 3 times 1 squared, and that will give us 2/3. So that is just the slope of the tangent line at the point 1, 1. So the slope of the tangent line is 2/3 at that point of this relation. All right, that's all the examples you need to do this homework. So the homework is page 139. And you can do 11, 13, 15, 16, 17, and 19. So 17 and 19, you will plug a number in at the end. These 4 are similar to yesterday's homework where you're just taking the derivative. All right, that'll do it for this lecture, and I'll talk to you on the solutions video.